So I will continue because you have already heard the introduction. So I will start with a few words about the motivation, and then, as you heard, I will show you some showcases of using deep learning for player detection, tracking, pose estimation, then action recognition, and spatiotemporal location in the videos. And of course, I will finish with conclusion. Okay, so what was the motivation? Well, it was a large amount of multimedia content in sports, and everybody now has watch and cameras and videos, and everybody is filming, and there are a lot of materials what can be somehow used. And also there is a great interest in somehow analyzing of these materials, not only for the players, but also for their parents if they are young, and also for trainers, for therapists, for journals. And so there is a lot of need to analyze the data. But idea is to somehow use as power as possible of the AI and to somehow analyze it more deeply. And I mean to follow the execution of actions, or to progress monitoring, or if very important, to prevent some injuries. And also, I would like to do that, but we are not at this stage yet, to somehow prepare the game strategy. So to be able to do this, the motivation was excellent results about deep learning, which is, well, I can say 10 years ago, where the models since 2016, but even 2017, have become so good in classification and have less errors than humans have. So we said, okay, can we use those models and to learn high complex functions and to deal with more application and more hard tasks, such as team sports, such as handball. So that was our motivation, and we wanted to start with that. So the idea, the goal was to develop a method for automatic player detection, tracking, and also for recognizing handball actions. So it was not so easy, because very fast we found that there is no data about that can be used for training the models. So we have to prepare the data set, and then also we have to train a model to detect the players and the ball, also to track the player, and to, after that, to recognize the player action or style, and also to use that in video materials. So I will start with first step, which was preparation of handball data set. We decided to record the materials during training and during matches. That was matches from the, well, mostly young players from 14 to 17 years. We used free GoPro cameras and free action cameras. We decided, we tested different locations just to take all the field and as many information as possible. We have cameras at the 3 and 5 meter and 1 and 5 meter. And we recorded the materials, and we have 4 hours of the materials. Usually there are 50 or 14 people at the videos, because it's mostly or both teams or players during the training session. What we found that it's a big issue, that the player size is from 40 to 250. And we had a problem with ball, because you can see it here. It's very difficult to see, but usually it's 1/18 of the height of the body. So when we do that, then we realize that we need, after preliminary experience, but that we need more data. So we even synthesize some set to have more data. After that, when you get the data, you have to prepare it for learning, for training. So we had to annotate the players. We tried and with segmentation, but then we decided that the bounding box will be good enough. And also we had to mark the video data and to mark all the actions that were performed at the video at one point of time. We haven't marked who is doing or performing each action, so it's a semi-supervised task. And also what can be seen here, that we have many players in parallel doing some actions, and also that the actions are lasting very well different. There are some short actions and some much longer. And so in brief, that is our data set. We have for now different actions, and well, it's not very balanced, but is the data set we are doing with. So the first task, which was, well, probably the easiest one, was player detection. It is the task that we want to, well, locate the player in the image. We used mask, RCNN, and YOLO. Later on, we decided that we'll stick with YOLO because we had good results and in a much shorter time. So here are the demonstrations of the both methods. They were first pre-trained on COCO dataset, and then we used transfer learning and learned them on our dataset. And here here are some results we already obtained. So the best results are YOLO with Selam, where the person accuracy is about 90. We have problem with detecting the ball. That is fitting because when we start doing with handball, everybody said me, you have to look at the ball because that's the case. But that was even the problem because the ball is very small. It's always in the hand of the player, and it's very, very difficult to detect it and also to track the ball. So it's a problem we are still dealing with. And also here, because we have many players, so it's not an easy task. Here with red are marked the situation with we are not satisfied. It is when the players are occluded, then the model can't see that there are two players, just one is marked, or sometimes even here we have one player that is not detected, or that is a coach that is not detected at all. So we still have many tasks to deal with and to better deal the model when the players are not occluded and even when they are not so big as in these images, we have good results, as you can see from the metrics. So when we can detect the player, we can even track them because we are interested to track the players and to, well, to find what are they doing. To do so, we have used tracking algorithms. Mostly, they are doing first by tracking and then by assigning the most similar player at the next frame to the tracker. So at the end, we have some situation like here, and you can see these IDs where we can track the player. When the situation is in this kind, it's very easy because they don't occlude, so you can see that the numbers or ideas to the players are, well, fixed. But in a real situation, we have many problems like this one, where the detector first, it's very hard for detector to detect the player, and then they change the position, they are occluded, and they change everything, even the speed, even the motion, even the size, and so it's very hard to be stick with one player. So that's the even challenges and issue we are dealing even now. We have tried different trackers, and well, it's hard to say which is the best one. We used Tractor and Deep Sort as ones they are tracking player, but in that stage of re-identification, they are using features and looking about the size and shape and tractor, even the motion to stick with that player that was detected on the former slide or former frame. Um, Then when we done that, we said, okay, now we want to even detect the poses of the players because we want to see if they are performing their actions well. So first we want to detect the poses. It's easy when you have one player, but it's very complicated when you have many of them. And here's just one example of one player and the stick pose and all the ankles and all the key, all the joints we are tracking. So when we got that, we wanted to analyze not one pose, but all poses during performing an action. So because to do that, what we had to do, we had to train the model. So we used 2D key points pose detectors and also trained it with the 3D pose estimation because to have a more robust model. So we used those combination of models and we are rather satisfied. The percentage of correct key points is around, the best one is 94%. So you can see the performance here. We couldn't just took the some pose estimation because the position that the players do, it's not very similar to the ordinary one when people are walking or I don't know, whatever. So we had to train the model at our data set. And in this case, we also used, because I said before that we use cameras, but also we use sensors and we put it on each ankle. After that, the case was to recognize the actions the players are performing. And when we do that, we can analyze different cases. We can look one player and performing one action. And this is one player throwing a ball. But then we can look the two players at the same field. This one is catching, so probably those two, if you combine those two actions, they are passing the ball. But also we can look all the team and they are all going for to attack. So we can analyze individual actions, actions between two people, and also group actions. It is very tricky and it's a challenging problem because on the field you have usually many players and also many times occluded. They are different position to the camera. They are changing their speed. They are changing their direction, and also during some sequence of time, they are performing different actions. So you have to find the beginning of some action to track them, analyze what kind of action is that, recognize it, and then track that action or compare it on whatever you have or you want. So what we have, we built a model for play-action recognition. We tried different models, and here are some results. The first problem was that the actions are not lasting, don't have the same frames. So we had to do with different strategies how to copy some frames if the action is short, or to select some frames from the longer action to fit the same model. So we analyzed with different strategies and found that there are some of them perform better and some of them perform less better. And also we find that the number of frames that we are using is important to recognize an action, which is, well, probably a normal case, because sometimes at the beginning, just watching 20 frames, it's very difficult to even for humans to set what the player will do. So probably you need to, well, that key parts of the action are already performed to recognize what the action is. Here are the situation. I don't know if I can do it much faster, but oh, sorry. Yes. So what we had here 2 cameras for monitoring, and also the player with sensors. So we are collecting both data, and the player should hit the ball in the goal. We done that just to be more precise for player pose estimation. And what you can see that during the performance, when the model recognizes the action, you can see the label about the action. All other actions for which model are not trained are not annotated. And also, because when you have many players, usually you are interested about only one that is, let's say, active. So we want to build a model or define some measure to somehow select the player that is, we call it active player. And we defined 3 measures, which is one is using optical flows, that one is using steps, and also some classifier to find a player that is active, which means that performs an action and not just standing or staying or whatever. Also, the same mechanism is used to analyze the videos, because when trainers, when they shoot video and then collect them, they just want to find interesting sequences without the parts where all the players are going to, I don't know, to drink water, or without parts where the player is just explaining what have to do, trainer, pardon. So we use that optical flow that defined the frames where is some action, and so it is much faster to find them. And also, at the end, what we want to do is to localize the actions during the videos. So we had to use more complex model, which is I3D CNN, which is a 3D model and has 2 streams. One is RGB, which is let's say standard model, but also we use optical flow, which is a part of a model to detect the players during video and the actions they are performing. So you can see the results here. When the model always detects the players, but when model recognized what the players are doing, it's written in Croatian, so the model then marks the action in a player. It was during a training session. And to find out how the model is, how model performs, we had ground truth data, and so those are results. Just a few words about my team. So we are all working in a laboratory of computer vision in University of Rijeka, and so dealing with these problems for last, I can say, 5 years. But still, there are so many open issues and so many work to do, especially in team sports, when you have many players, when they are far away from cameras, and if you want to track the ball, it's a problem because the ball is very, very small, and most of the time is in the hand of the player. So probably some game rules can be applied. And also we have, during tracking, we have a problem because, well, many times we are losing players, they switch the identity, and also probably some knowledge about the game can help us to have better performance. And the last one, what we want to do is to compare is the player poses, which is not an easy case because the players differ, and it's they don't. There are different location of the location from the camera and different angles, so we have to many job to normalize the images and to compare them. That will be all. So, if you have a question.
Yes. What stage is this project now at?
It's finished.
It is finished?
Yes.
So is there going to be a continuation? Or
yes, what? I hope so, yes.
Yeah, so I mean, with the handball.
Yeah, we have also worked with swimming.
Okay.
But so we are just at the beginning. So yes, but probably I hope so that we will also continue to work even with handball.
Okay. Questions? Come on, it's sports. There must be. Can I get the mic here?
All right, it's a nice use case. My question is, have you tested this using live data from an actual game, like feeding a TV stream into the system and then testing whether it works or not?
Yes, yes. Yes, we've done that, but at the beginning we wanted to test it, even to learn the model using live data. But then we found that it's a very complicated task, so we switched to the training data because usually we have one player performing one action. So yes, but when you see, not so good results we have in the live data in a match.
In your opinion, what's stopping you, and how far are you from that point?
Well, we have to work more. Well, maybe more data will be, but also we have to retrain the model. And as you see, we haven't had. Well, we work with 3 cameras and 2 action cameras, so it's not big, not many data that we collect. But I think so that. We can improve results during learning on more data. That's the. If you ask if it's I'm not sure how satisfied will be the audience with the results, but yes, I can show you. You know the real later. Yes.
All right. Thanks.
So ideally, how many cameras would you need to say, okay, now we can collect the proper data? And you're using some sensors on the trainings.
Yes. Our idea was that we want to build a model that can work or perform well in, I can say, cheap use cases. So it means that even if one camera, if you are collecting data with one camera, to have satisfied results, because we are not MVC or we are not dealing with teams which have have a lot of money to spend for all the sensors and everything.
But once when you create the good model, everybody will want to buy it. So then you will get to those
probably
rich teams. Yes. Any other questions? Here? Where's the microphone? It's coming here.
Hello.
Hello.
Very nice work. I want to ask you if this model can be extrapolated to different age, different genders, different body types.
I hope so, yes.
So you didn't have the opportunity to test yet?
No, we were tested, yes, on matches, yes, and also on players what we have, but it's not very difficult. If you ask me if a model performs well on, I don't know, on basketball, probably not so well, but the tracking of the players and, well, the detecting, it should work, because it's, well, it's the same scenario as you have seen. What we had the problem, it's the difference or the specification of the handball, because, for example, when we use the standard model, which is trained on passengers, they are very rare raising their hands and doing something like that, and also they are not jumping. So at the beginning, the model had cut all the hands, and also during jumping, we were all, well, all the figures were without legs. So we have done that, and it's good. The model performs well. Okay.
Thank you very much. Very nice job.
Thank you. If there are no more questions, then I will thank Marina for this good presentations. You mentioned swimming. That would be an interesting thing to learn about. What were you measuring with? Just the speed or what?
We want to measure everything, even the style of the player, of the swimmer, and also the trainer said me that they want that we help them to identify the swimmers. So we have to find the way to somehow, mark one player and to find the player during the
swimmer,
videos, yes. The swimmer in the video. So because the trainer wants to track that particular swimmer and to detect the performance of the style and everything. So it's next step what we are doing.
Okay. Marina Ivasic Kos was here with us today.
Thank you.